At first I extend a little bit the base, the foot plate, with a piece of hardwood under it to give it a better, a more stable standing position. But you can even also enlarge it. That's not really the problem. But these little bits, it already helped, and you can clamp it down, you know, on another blade or your workmate. You can put a few clamps on it. It's not really in line, the foot plate and the rod. And then you can't change that because it's a prefixed, a drilled hole with a clamp. And what I did is I leveled out the drill table itself with some shims under it to get it really straight like this and like this. So that's to both axes, that it's a straight, square situation. Well, the next problem what I encountered was that there was a bit of play in the drill holder, the one who goes, who brings the drill up and down, and the rod, the upstanding column, this one. So there was a play in between, and there were no adjusters like this. This is an Allen bolt, an inbus bolt, with a contra nut. That's in my case M6, but you can do it from any thread or any bolt. And of course I brought in some thread, and then I inserted the bolt in the top side as well. Same question, same problem. So this is one of the first things what I did. Some do have it, some drill stands, they come with it, but this one wasn't featured with it, so I had to make that myself. And now he's really tight, or not so tight that he can't move, but the play is out of it. That was the first thing what I had to do. And if you have the same case, I should advise to do that also. Well, if you have the table from the drill press and you extend it, and also with a factory table, what you also always should check with every drill combination or machine is the table perpendicular in 90 degrees with the drill. So I buy a little triangle. We call it a geo triangle, and you check that if you see any light appearing between the drill under and the drill above. Now in this case it's dead on. Yeah, another thing about the drill table, some people they like to include a fence with T-rail. I don't. I don't like the fence with the rail. Maybe in future, I don't know. For now, I do it like this. I always like to do it with a 90-degree profile, aluminium, and two clamp bars. And it goes for me just as quick, clack clack, and I give it a few knocks with a hammer or whatever. Because in a way, it always goes about the pivoting point. This is important, this direction. And if this is a bit to the front or to the left or to the right, it doesn't matter that much. It's from the rail in here until the tip of the drill, the center of the tip of the drill. That's the most important. It's a pivoting point. So it doesn't matter that much. Well, if you start to build such table, there are a number of points of attention. You see in here the vertical sheet, and the vertical sheet is made out of 4 sections. A top section, a bottom section, and 2 side pieces. I did that because if I don't need on the job or whatever the big sheets, I can just work with only the top sheet. And if you can do it also from a full sheet, it's just what you want. This is then a sheet I used 3 feet by 3 feet, and for me that's sufficient. What is highly important is that these pilot holes, the adjustment holes, they are in there 10 centimeters or 3-4 inches apart. That is just what you want. And they have to be really in line, either the left row and as well as the right row. So all the points have to level up. Well, as you see, the vertical sheet, it sticks out a bit above the plate. And in this case it's a good 3 centimeter. And that works right away as a drill fence. Well, there is an addition or a change. This one, the old support beam, I changed it for a fatter one. This one is 45 mil and it flexes. So I went for a 90 mil, which doesn't flex. Also, if you drill out of the center, and you keep the pack a little bit on both sides sticking out, you can use the same support beam on both sides, and you even can turn it upside down, so then you have a little bit more height. Then you don't have to change the drill setting. It depends, you know, with the panel height. So this is going to be the new size, 90 mil. So right away you can drill 2 holes, one in here on the right side and the other one further on the down side, on the left side. Also, these holes, they have to be absolutely accurate with the top of your base plate. If not, it's out of line. And everything what you put on it is also out of line. So that has to be really in exactly the same height. Well, here you see the vertical sheet. And in my case it's 90 by 90, and I made it consisting out of 4 parts. The top part, 2 mid sections, left and right, and a bottom section. For me that's handy. I had these pieces laying down, and for me it's handy because if I have only small parts of wood, small panels, I use only the top side, and then I don't mount the other 3 parts. But you could do it also out of a full sheet. It's just what you want. Then on the sheet I created first a drill fence. This top part, it's going to be the drill fence. I choose for 3 centimeters, but you can take also 5 or whatever. And that part sticks in the end above your horizontal table, so that it's possible to put a clamp on it and to clamp your panel off while drilling. Well, because the sheet is 90 centimeters and I stay 5 centimeters out of the edges of the sheet, of the plate, the distance between the holes on either side is 80 centimeters. Those 80 centimeters, you bring them in the support bar. One hole 5 centimeters from the side and the other hole of 80 centimeters, on 80 centimeters. 8 mil, and drill them straight and absolutely in the same size from the side, one of the sides, and the other hole exactly the same size also from the side. Otherwise it's going to be crooked. Then your hole bar is off. Then I took an aluminium profile, 90 degrees, or a straight piece of aluminium, and followed the baseline, pencil line on the 3 centimeters, which is the underside of the drill fence, and connected it with 2 clamps. So now we have a straight attachment where we can put a ruler against. Then you bring in, or you bring on, the square line. And I put the square angle on the 5 cm mark. And I draw a line. Then I have a perpendicular line in combination with my baseline. Now I attached a ruler. I can set out all the different still to drill holes. So now we're gonna drill them with 8mm, and I do that with a drill guide. Because we have already this set of holes, I'm gonna use now the support bar. Put the drill in it, or you do a dowel in it. Anyway, so he's tight in the hole, can't move anymore. Now we are on the other side of the bar, the support bar, and we still have to drill now in here a hole. And this drill has a point, so if we stick it in and he is against the bar, there is no problem. We can give it a punch mark. And after making the punch mark, we remove then the whole bar. And do with the drill guide, we drill the second hole. Well, every time when you do a new set of holes, measure it always from the baseline. Now the second level, it's going to be in a way the same procedure as with the other one, only we don't use anymore the aluminium profile to lean against, but just to measure. And he follows the baseline. So we put in a drill in the second hole, more or less the same distance, parallel with this one, and on the hole line we do a readout, and this readout, what you find in here, we keep it also to the other side. So then we go to the other side, and the other side we do the same readout on the square angle. Bring the camera to you that you can see it well. Now then we do the same procedure. If it stays in the same distance, punch mark and drill with the drill guide the second set of holes from the second level in the plate. And this procedure, what we do now, you repeat it until you are to the underside of the plate. You know, the next all the sets of these holes. And we have parallel holes on either the left and the right side of the whole plate. Well, now we have to bring in an attachment. This is an aluminium profile, 90 degrees, on the other side of the plate. This is then the other side of the plate. I turned it, and now you will see here the back side of the holes. This mark here is then the mark of the baseline, what we previously used to drill the holes on the other side. We push it through, write it through, and we make in here the same baseline. In this case it's then, in my case, 3 centimeters. For placing the attachment profile, and this profile hangs on the top side of our horizontal table. Now here you see a top view from the aluminium piece, and I just gave it some attachment screws. And now we can hang the vertical part on top of the horizontal table. Well, we hung it on the table, and now you place a clamp, you know, loosely, so that it doesn't fall off. It's still not really in angle, but that doesn't matter yet. What you're going to check is, because we still have to mount in here a side plate, or a square one or whatever, Anyway, to keep it in a certain angle. Then we're going to see if the plate lines up with the side of the table. Perfect. That's okay. Well, the next thing what you do is to line up the vertical sheet with the drill. So I turn the spiral really with the under spiral in the bottom of the drill or in the top of the drill. I turn it to the table, and then I hang a light behind the drill and see if I can see some light between the end of the drill and the beginning. And if you think it's dead on, and I do that by putting some sort of a clamp under a heavy clamp on the bottom of the table over here, so it has some weight and it stays in the same position. And then you knock it a bit to the left, you knock it a bit to the right to get it in the right angle. And if it's dead on parallel with your drill, you know that that is also the position. And then you can put some screws on the side of the board for the fixed position now. And now it should be in line. Yeah? To mount these top screws. With this one you still can wait, but at least these and these. So this is then, it forms a certain line. And because we know that the drill is now in position, change the view, you see in here the drill, it's now really parallel with the sheet. So now we can drill off this line of screws and really to fixate it in this position. Then you start, of course, if it's lined up with the bottom screw in here. This one you put in first and see that it doesn't run away, so that near the drill the position of the sheet will keep on being parallel with your drill bit. Place then the last or the bottom screw and continue the line of screws bottom up to the top. And now the vertical table is attached in the fixed position by means of the side sheet. Then we place a perfectly straight drill bit. I take a bigger one for this. This is ½ inch. And first you check it on the glass plate if it's really straight, the drill bit. If not, we have to see for another drill bit. Take a straight drill bit, put it in the drill and place it almost on top of the board. It's still a bit loose, so it doesn't touch the board. So we still can go all the way. Now we take the triangle and measure. Well, as you can see, it's pretty much off. It's not really an angle, but this is what we're gonna adjust. In my case, the left side of the table is too much down. This should go up. So what you do is you place a few shims. Now by putting various shims or whatever you have under the aluminium profile, we raise or lower the table. In my case it has to raise. Well, after lining it out with shims and filling it up, I'm pretty much on a 90-degree angle. Well, the shims, what you use to fill out, you always can glue them under. Now you see that from the side panel in here we have a bit of leftover. Now that's no problem, that you can always router away. If you put the router against it, you just router it off and then it's nice flush. Now I placed a sheet of wood panel on top of it. And we're gonna see if it's really perpendicular with the drill bit. Well, now we're gonna see the side axis. Well, dead on. Now we placed a dowel in it, and now we're gonna see 6mm. Now we're gonna see if it's really perpendicular to the plate, and in this case it's exactly right. Yeah, there's no light shining through. That's okay. I think it's a very precise drilling. I don't know if you can see that, but it is just maybe it's 1/10 of a millimeter off, not even more. Well, now we're gonna see how much difference I have in between of the plates, or between the two plates, and that's a 1/10 of a mil. I don't know if you can see that. It's a 1/10 of a millimeter. The front of the plate it's flush, and in the end I have a little discrepancy of a 1/10 of a millimeter. Well, for me that's okay. Well, this was absolutely a cheap solution, because I built it all from leftovers from the workshop, so it didn't cost me $1. Well, it was quite an adventure, and I'm happy that it succeeded, and especially because I have now the ability to drill extremely large sheets of wood, like 8 foot by 4 foot high, and for me that's a big advantage, so I'm very pleased with it. And I hope that the video was clear enough for you people, maybe to duplicate it for yourself or to build it for yourself. And I wish you then lots of success with it for the future. And anyway, thanks for watching, and maybe I see you next time. Bye bye.